Satu.
Hello, we are presenting our uh, group discussion result in polymer in engineering. My name is Muhammad Edo Altair.
I'm Muhammad Dipa B.
My name is Pratama.
My name is Atalla Choliq L.
And my name is Heyza Aditia T.
Okay, so first up, what are polymers? So, as the textbook says, polymers are large molecules made of small repeating units called monomers. But we don't actually know what monomers are, so which is why I would say it's best if I use an illustration to help us understand this definition. So first, we have what's called a monomer. So basically, this is the base molecule, and how it comes to be basically the one under it is called a polymer, which has a bunch of repeating units, as said from the definition. And the one on the right is the repeating unit, which means it's basically the pattern that is shown here. So here are some, they're basically categorized generally into two categories, which are natural polymers, which include proteins, nucleic acids, RNA, and rubber, so which are polymers that can be found in nature, whilst there are also synthetic polymers, which are polyethylene, nylon, polypropylene, and polyvinyl chloride, or just PVC. And provided below is the repeating unit from PVC. So how you can write your repeating unit is basically you can remove the double bond and put brackets around it and use N. So N is basically how many times the monomer repeats itself. Also, a picture here is of an RNA, which is also considered a polymer with four monomers here, which are ACGT, if you learned that in biology. After that, I'm gonna explain about how these polymers comes to be. So for example, like ethene, how can it become polyethylene? So basically, with monomers which have double bonds, they basically go through what's called an addition polymerization. So basically, there's an initiator which attacks the double bond and breaks it. So it makes it be able to link itself with many other repeating similar similar monomers, which is why it can come to be as polyethylene. The same goes for chloroethane. Okay, next is condensation polymerization. So this happens where basically for monomers which doesn't have a CC double bond. So like in the example here, it's functional groups, which are these bits on the ends. They basically react with each other so that they can combine. So for example, this OH and H from these functional groups, they make a byproduct of water, but they also make a polymer, which is terylene or PET. Uh, Other than that, there's also such things called copolymer, which is very similar to composites, in which the manufacturing of such is basically using two different monomers so that you can get the desirable properties from one of each. Like another example other than terylene here is like ABS, which is something that is the main component of Legos. Okay.
So polymers are divided into two main types. The first one is thermoplastic polymers and thermosetting polymers. Thermoplastic are polymer that soften under heat, which will eventually liquefy and harden when cooled. Such process is reversible and can be repeated many times because the polymer chains are not chemically cross-linked. Example is polyethylene or PE, polypropylene or PP, PVC, polystyrene or PS. On the other hand, thermosetting polymers are permanently hard materials that do not melt or soften upon heating after they have been cured because their polymer chains are extensively cross-linked. Example being epoxy resins, phenolic resins, and polyurethane.
Yeah, I'd like to add also like these are properties which engineers should consider when picking up a polymer, especially let's say in the uh, automotive sub branch where when polymer is used, they're quite susceptible to heat. So we must know how they might behave under a certain amount of heat. Okay, next.
Okay, next are the properties of polymers. First, mechanical properties. Basically, for mechanically, polymers can like behave something like soft gummy bears from super tough to like skateboard wheels, and it all depends on how long the chains move. So yeah, like for mechanicals, they can range from like very soft and flexible to strong and rigid. What I meant by the soft gummy bears and like the skateboard. And not only that, they can also stretch, bend, and deform more easily than metals because their long molecular chains can move and slide under load. Some polymers are tough and absorb impact well, while others may be more brittle. Their stiffness and strength and elasticity also change depending on their temperature, making them behave very differently in hot or cold conditions. Next is chemical properties. Chemically, polymers have strong chemical resistance, meaning they do not react easily with water, acid, or many common chemicals. Their long molecular chains also make them stable, but they can slowly break down when exposed to heat, oxygen, or UV light. And the amount of cross linking in a polymer affects how chemically stable and heat resistant it is. These chemical properties help determine how long a polymer lasts and when it can be used.
Okay, next we are going to talk about the application of polymers. So in general, polymers are used in many fields. The first one is about plastic, and then also in high-tech technologies like aerospace, medicine, and electronics, polymers also used because these polymers have properties such as lightweight, strength, durability, flexibility, and resistance, making them essential for modern life and advanced technology. And then the application of polymers, especially in engineering, polymers are used in engineering because they are lightweight, corrosion resistant, and easy to shape into complex parts. They are commonly applied in components such as gear, bearing, seals, and housing because their low friction and good durability improve machine performance. Their versatility and low cost make them ideal for many engineering applications.
Okay, that's all from us in this presentation. Thank you for your attention, and see you next time. Yeah.